Now we're going to be measuring the volume of these two items. The way I'm going to do this is I've set up a cup of water on top of the scale, and I will be measuring the water displaced by my items. So again, I'm going to be floating these items inside the cup. I'm not going to allow them to touch anything inside. And then I will be measuring the water displaced. And as you can see, it's about 2.1 grams of water displaced. Again, you got to remember also that 1 gram of water is a cubic centimeter of water as well. So that's what allows me to do this. So it's about 2.01 rather. Now I'm going to do the same for my disc. I'm going to float the disc inside of the water to see how much water is displaced. First of all, I'm going to tear my scale again, make sure that it's 0 again. Some of the water was picked up by the cube. So now I'm going to measure how much water is displaced by my disc. So it's about 4.47, 4.46 grams of water, 4.46. Again, my hand is not the steadiest. Four point four seven. 4.47. So it's 4.47 for the disc. 4.47, and then it was 2.01 cubic centimeters or cubic centimeters. Again, you got to remember that 1 cubic centimeter of water, it's also equal to 1 gram of water. So this is what allows me to interchange measurements from back and forth from volume to grams to weight. Okay, after punching in the numbers in the calculator, I am dividing 39.74 grams by 2.01 cubic centimeters. I get a density of about 19.79 for this cube. There's 3 possible candidates within the periodic table as to what this is made up of, because these elements happen to have a density around the 19s. 19, as a matter of fact, plutonium I think is 19.8, uranium is about 19.1, and this one is tungsten, which happens to be about 19.3. So none of those match this exactly. However, on the disc, after I dialed in the numbers, 12.18 divided by 4.47 grams per cubic centimeter, I get a number of 2.72 grams per cubic centimeter. And that happens to match exactly the density of aluminum. So again, I assign aluminum to my disc, which is the speed of sound through aluminum is 6,420 meters per second. So I'm gonna go ahead and test the disc as and treat it as if it was aluminum. And this, I'm pretty sure this cube is not made of plutonium or uranium or gold, which is another element that is pretty close to that density of 19.79. So I will go ahead and assign it the value of tungsten, which is about 5,220 meters per second. Okay, after punching in the numbers and doing everything that I needed to do, I'm gonna go ahead and measure the thickness of this disc and treat it as if it was aluminum. So I've already dialed in the velocity for aluminum, which is here in the sub menu. So I just hit OK, highlight aluminum, hit OK, OK again, then escape, and then it should have the velocity for aluminum. So yeah, I've already calibrated my tool, so no need to do that. So I'm gonna go ahead and just measure the thickness as if it was aluminum. So as you can see, it's about 3.9 millimeters thick. So this disc is about 3.97 millimeters thick. Now I'm gonna compare that reading to my digital caliper. I'm gonna go ahead and make sure that you set it to 0. Okay, cool. So we're gonna measure on the same spot. And yeah, it's pretty close. 3.92, 3.97. So therefore, we concluded that this disc is in fact made up of aluminum. There's the speed of sound is very specific for this particular material because it is so high and so different from all the other materials. So there you have it. Now let's take a look at the cube. Let's measure the cube. So I'm gonna go ahead and treat the cube as if it was tungsten, because the reason being is that it is, even though plutonium and uranium, the density of it is close to 19 point something, the speed of sound is different than tungsten. It's way different. As a matter of fact, plutonium has a speed of sound of 2260 meters per second, and uranium has a speed of sound of 3155 meters per second. So I'm gonna try the most different one first, because that would, like, if I in fact can prove that this speed of sound works with my cube, and then I can rule out these other two. So I'm gonna go ahead and put some ultrasound gel on my cube. Now I'm gonna set my probe to measure the speed of sound through tungsten, which is already done. It's about 5,220 meters per second. Now I'm gonna calibrate my probe. Hit escape, calibrate. And it's ready. So now we're gonna measure the thickness of this cube, which happens to be about 12.82 millimeters measured with my probe. So now we're gonna go ahead and compare that measurement to our caliper reading. And make sure it's at 0. So we're looking for 12.82. And there you have it. 12.84. That's fairly close. So let's say what happens What would happen if we were to dial the speed of sound of plutonium instead of the speed of sound for tungsten? Let's change. Plutonium is a speed of sound of about 2,260 meters per second. So now let's treat this as if it was plutonium. So we go here to our probe, scroll down, go to our custom setting, and then let's change this up. We're gonna hit OK. So the value we're gonna put in instead of 5,220 is 2,260. So I'm gonna go ahead and leave that 0. Scroll to the left with our valve button, then move up to 6. Again, scroll to the left and leave it at 2. Then scroll to the left again, go down all the way to 2. So now we have dialed the speed of sound through plutonium. Let's see what happens if we measure this cube with the speed of sound through plutonium. So hit escape. So again, same procedure. We must calibrate our tool before we use it. Hit escape. Scroll up till you hit the highlight count. Hit OK. Calibrating. So now it's calibrated for plutonium. So we're going to treat this cube as if it was made up of plutonium. So now put our gel again. Now we measure the thickness of it. And it's measuring about 5.55 millimeters. That's my reading on my scanner. 5.55 millimeters. And then again, we know from the previous measurement that this cube does not measure 5.55 millimeters, that it in fact measures around 12.84 millimeters. We've already measured it. So if you want to see it again, about 12.81. So in fact, there is nowhere near to 12.84. This is in fact half the thickness of it. And it makes sense because this is about a little bit less than half the speed of sound, which tungsten is. So that's how you prove that it is not plutonium or uranium, and that it is in fact made up of tungsten. So therefore we conclude that our disc is made up of aluminum and our cube is made up of tungsten. Okay, so there you have it. We've used this ultrasound thickness gauge, and as you can see, it has many useful purposes. It can also be used to with gold, obviously, with gold coins and gold bars. This particular model has you can set the tolerance up to, like, I think up to 200 millimeters. That's the thickest measurement it will do. Something that measures 200 millimeters thick. So there you have it. Again, guys, thank you for watching. And in my next video, I will be showing you a few gold coins. A few I will be showing you one of my coins in my gold coin collection, how to test for that. Again, thank you for watching, guys, and see you next time.